give you this NaCl, a lot of the Na and Cl. You can pick this as a unit cell, that the Cl atom at the corner, or you can pick this as a unit cell, that the sodium at the corner, doesn't matter. Okay, both also will fulfill the requirement as a unit cell. Okay, so this is the structure of the NaCl. So this is one unit cell. This is another unit cell. This is another unit cell. This is another unit cell. Remember that I told you? So I know that this Na and Cl is one basic. Then this NaCl is another basic. This NaCl is another basic. So it's an orange, blue, orange, blue. So orange, blue, orange, blue. They're exactly the same. These two are the 1 and 2 are exactly the same basic. You cannot pick that. Here you pick orange, blue, then here you put blue, orange. No. Then these two are different kind of the basics. The basic should also should be exactly the same. So orange, blue, then this one should also be orange, blue. Okay. So now you can see that for this structure, it is the face-centered cubic, right? So corner, 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 then on the middle of the plane. So just now I introduced you the sodium chloride. So now the next simple structure that I will introduce you is the cesium chloride. Okay, this is the structure of the cesium chloride. Then you may think about it. Is it belong to the simple cubic, body center cubic, or face center cubic? What's your answer? It looks like body center cubic, right? Is it a body center cubic? The answer is no. It's not the BCC, not BCC. Why not BCC? Because for this case, Cl is not the basic. For CsCl, the basic is CsCl, and it contains of two atoms, which are Cs plus Cl. But the basics is not Cs, also not Cl, but the combination of Cs and Cl. Therefore, the basics is something like this. Okay, so for this case, the primitive cell is simple cubic. So this is simple cubic, not body center cubic, because each atom is at the center of the cube of the atom of the opposite kind. And if I ask you what is the nearest neighbor, the nearest neighbor atom is 8. Okay, just like body center cubic. If I ask you the nearest neighbor atom, then you have 1, 2, 3, 4, 5, 6, 7, 8. 8. But if I ask you what is the nearest neighbor basic, when I say basic, then you have to consider it as a simple cubic. Okay, so there are other examples similar to this one, like CuZn, TiBr, AlNi, aluminum nickel, then AgMg, argentum, magnesium, silicon, then beryllium, copper. Okay, why I consider CsCl as a simple cubic, but not the body center cubic? Okay, you can see that this is when I stack a few unit cells together. So okay, this is the structure. Okay, so now these two, okay, let's say the orange one equal to CS, and then the blue one equal to CL. So orange blue becomes CS CL, right? So this is one basic. So this is one basic, this is another 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 basic, this is 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 basic. So from here, do you think is it still a body-centered cubic? No, right? Because when we want to draw the unit cell, we draw it based on the lattice point. So each basic will occupy one lattice point. So this basic will occupy one lattice point, this basic will occupy one lattice point, this basic will occupy one lattice point, one lattice point, one lattice point. So when I join all the lattice point, it looks like this. Okay, so this is one lattice point, another lattice point, another lattice point, another lattice point. So it is a simple cubic structure. Okay, when you look at this structure, it looks like body-centered cubic because you consider atom, Cl atom and Cs atom, which is not correct. Because when you want to consider the unit cell, you have to consider the basics. Okay, so for this case, the basic is CSCL. So these two belong to one basic, just like this case in 2D. These two belong to one basic, these two belong to one basic, these two belong to one basic. So for CSCL, the underlying Bravais lattice should be simple cubic, and this is not body-centered cubic. Okay, unless if the case is this is cesium, this is also cesium, this is also cesium, this is cesium, all are red, all are orange color. Then if they are all cesium, then for this case, this is BCC because the basic is cesium. This is one basic, this is one basic, this is one basic, this is one basic, this is one basic. So the basics will occupy one lattice point. Okay, so this is one lattice point, another lattice point, another lattice point, another lattice point. So when I link the lattice point, I found that this is a structure of BCC. But the problem here is CFCL have only one basis. Have only one basis. Okay, so this is only considered as one basis, not two. So you have the structure like this. So this structure is same with this one. Okay, and both of these belong to simple cubic structure. Okay, this is in 2D. Okay, if I draw in 3D, so I'm not sure you notice or not. Let's say the red one,